Alright guys, welcome back today. Yesterday we reviewed Pythagorean theorem. Now we're going to talk about the converse of the Pythagorean theorem today, as well as a couple other things you need to know about acute triangles and obtuse triangles. So, first thing we are going to cover is the converse of the Pythagorean theorem. So, as you know, usually when we cover a converse, it's the opposite of what we just did. So we just said if a squared plus b squared equals c squared. Okay, we know that to be true if we have a right triangle. Now we can say the same thing. If we know a squared plus b squared equals c squared, then we know, or we can conclude, that we have a right triangle. So originally we knew we had a right triangle, so we could prove a squared plus b squared equals c squared. Now we know a squared plus b squared equals c squared, so we can conclude that the triangle is right. So for these first four practice problems, essentially we are just proving that this triangle is a right triangle by proving a squared plus b squared is equal to c squared. So I'll walk through this first one with you. We know our legs are 6 and 9, so we should say 6 squared plus 9 squared should be equal to the quantity 3 square root of 13 squared. 6 squared is 36. 9 squared is 81. Remember, when we have a quantity like this, everything under or inside of the parentheses must get squared. So this is really saying 3 squared is 9 times the square root of 13 squared is 13. So this really just becomes 9 times 13, which ends up being 117. And then 36 plus 81, also 117. So this is indeed a right triangle. So from here, the next three examples are essentially the same thing. I need you to prove for me if they are right triangles or not. So if you'd like to pause the video, go through, do your work, then come back and check and make sure you're on the right track. So second one over here, our legs are 24 and 16. So 24 squared plus 16 squared should equal 29 squared. So if I grab a calculator, we know that 24 squared is 576. 16 squared is 256. And 29 squared is 841. 576 plus 256 is equal to 832. So that does not equal 841. So this would not be a right triangle. Down here, we have 5 squared plus 4 squared equals 2 square root of 10 squared. 5 squared 25, 4 squared 16. This is going to end up being 4 times 10, which is going to be 40. So 41 does not equal 40. We would not have a right triangle for this one either. And then last one here, 15 squared plus 18 squared is equal to 3 square root of 61 squared. 15 squared is going to give us 225. 18 squared is going to give us 324. 9 times 61 is going to give us 549. 225 plus 324 is also 549. So this one does indeed give us a right triangle. All right. Next two things that we're going to go through are acute triangles and obtuse triangles when using Pythagorean theorem. So, when dealing with acute triangles, okay, if the square of the length of the longest side of a triangle is less than the sum of its squares of the lengths of the other two sides, then the triangle is an acute triangle. So essentially, instead of a squared plus b squared is equal to c squared, If c squared is less than a squared plus b squared, then we know the triangle is acute. The flip, or the reverse, is also true. With obtuse triangles, if c squared is greater than a squared plus b squared, then we know it is obtuse. So if it's equal to, it's a right triangle. If c squared is less, it's acute. If c squared is larger, then it's obtuse. So 3 possible outcomes, tells you right away whether it is a right triangle, an acute triangle, or an obtuse triangle. So as we flip it over here, number 2, can segments of 2.8, 3.2, and 4.2 feet form a triangle? First off, this is where we have to remember our lengths that can create a triangle. The smaller sides must add to be larger than the largest side for it to be a triangle. So in this case, 2.8 plus 3.2 gives us 6. 6 is indeed larger than 4.2, so this can form a triangle. Now, is it acute, right, or obtuse? So this is where we can use Pythagorean theorem to determine if it is acute, right, or obtuse. So we have 4.2 squared. I'm just going to put equal to for now, but this will change depending on what type of triangle it is. 2.8 squared plus 3.2 squared. So if we square these values, 4.2 squared gives me 17.64. 2.8 squared is going to give me 7.84, and 3.2 squared is going to give me 10.24. So 17.64 is equal to 10.24 plus 7.84, which is going to be 18.04. So in this case, c squared ended up being less than a squared plus b squared. So this would be an acute triangle. So why don't you guys go ahead and try number 3, and then we will get to number 4 after that. So go ahead, pause the video, try number 3, see what type of triangle we have there. So in this one, let's make sure first off, 6.1 plus 9.4 is going to be much larger than 11.3, so this will be a triangle. Now let's figure out what type of triangle we have. It's equal to 6.1 squared plus 9.4 squared. So if we go ahead and square 11.3, we end up with 127.69. If we square 6.1, we end up with 37.21. And if we square 9.4, we end up with 88.36. So if we add 88.36 and 37.21, we end up with 125.57. That is going to be smaller than c squared, so c squared is larger, so this would be an obtuse triangle. And this last one here is more just kind of for you to think about, but let's say we're helping to install a light pole in a parking lot. When the pole is positioned properly, it is perpendicular to the pavement. So I've got pavement, I've got a light pole that is going to be perpendicular if it has been installed properly. How can you check to make sure the pole is perpendicular only using a tape measure? So, using a tape measure, we could measure the height of this, so we would know the height of the light pole. We could also just pick a distance from the base of the light pole, call it right here, and measure this distance here. So we've got the height, and then we've got the distance away on the ground, and then we should be able to, using that tape measure, also measure from the top of the light pole to where this distance is. And if we have properly installed this light pole so it is perpendicular, c squared, or from the top of the pole to this spot that we've picked, should be equal to the sum of the height squared plus this distance squared. Essentially, you should be able to figure out if you've installed this light pole properly just by measuring and using Pythagorean theorem. Here, just a little bit of review over what we've covered today. If it's equal to, c squared is equal to a squared plus b squared, right triangle. If it's less than, acute triangle. If it's greater than, obtuse triangle. That's all we got for today. Please make sure, guys, you go check out your homework assignment that's on Mudge. Get that done and turned in for me by tomorrow. Tomorrow we will have another video, keeping moving on as we kind of move through this, and I will be back in a couple more days. All right, fellas, we'll talk to you tomorrow.